Okay, hi. So my name is Lior, and I would like to talk to you about today about how we can use AI more to do more than just coding in software engineering in general, specifically focus on designing with AI. So I guess at this point, we've been with AI, LLM specifically, for a few years now, and we've all had this kind of aha moment when we typed something into a chat or a coding agent and something and just saw the LLM basically spit out working code, which is very nice. And at this point, I think we all understand that coding in itself has really improved with AI. Our velocity as software engineers when it comes to the actual coding is faster, and we can already feel this. The question, of course, what about the general productivity of software engineering in general, beyond just coding? Because anyone who's been in this business for more than a week can tell you that coding was never really the bottleneck for production of software, right? The actual writing of code was never really the big issue. Okay, there are a lot of stuff going on around this that take more time, and the fundamental question I'd like to present is whether we can do better with AI to software engineering in general. And like I said, coding in itself is pretty much a solved problem. I mean, it gets better all the time, and of course, there are still issues, but it's way better than it was 2 years ago, and it keeps improving all the time. And we're already seeing the velocity improvement. The question is, what can we do more when it comes to productivity in the field, in the real world, where we see these kind of problems? And specifically, I'd like to tackle the question of, can we leverage AI for doing design of software systems? Note specifically that I'm talking about the design of the system, meaning what components are there, how they interact, questions like where's the data stored, how is it secured, how do we obtain performance, etc., etc. This is different from software design itself, the design of the code, which I think, again, coding agents at this point, like Claude Code, Cursor, Codex, etc., they all do pretty well, and they keep improving all the time, definitely with the latest models. But designing a system is kind of a slightly different problem. They're related, of course, but it's a different problem. And it's more a question of trade-offs and really consolidating different aspects, sometimes addressing constraints and problems that we might have in the system design, sometimes not even technical problems, but business and human problems, so to speak. And there's, in the real world, there's of course a lot of brownfield complexity, meaning it's not just new projects and greenfield, so to speak, projects. And the question is, we can leverage AI for coding, but can we leverage AI to do this kind of design consistently, meaning not just as a one-off activity? And can we do this at scale, right? Design a software system, but also design the evolution, new features, fixing bugs, refactorings, etc., etc. Okay, so that's the fundamental question. Now, let's say, a first attempt or a first approximation of this would be, let's just spin up something like ChatGPT or Gemini or Claude, whatever, and present the problem, ask questions, and get a result back. And I think we've all done it in one way or another. I've done it myself. And we all know also the, let's say, limitations of this approach. We know that LLMs can hallucinate. We know that they tend to be overconfident, trying to please the user who is asking the question. We also know that they tend to what's called early anchoring. They tend to go with some solution and stick to it or try to sort of make it work even when you push back, etc. And you can probably do some work by you pushing back and providing this kind of adversarial pressure. But even if you manage to do it to some degree, it's still not done at scale if it requires a human to sort of chat with the LLM. It's still not something that we can let the LLM be autonomous with. So this approach, while it can be useful in some cases and beneficial, it's not really answering the question. Which then led me to think about, how do we do it? Humans, how do we approach questions of system design? And the answer is, we do it with other humans. It's a team effort, right? We either sit in a room and draw on some whiteboard and discuss the different trade-offs, the problems, the requirements, etc. Or we write a draft and we share it on email or Slack or whatever and ask for feedback and then get feedback. Sometimes we argue, we get the product managers to weigh in, we get the DevOps guys sometimes, the architects, etc. But the key point is, it's a team effort. We have different people with different perspectives, different expertise and experience coming in and each weighing and giving their opinion, hopefully. And sometimes it's a heated argument, but it's still there. And it's important to understand, we also have this kind of convergence mechanism. It could be just a vote, but it's often the manager or the architect just decides what to do, given all the different considerations and constraints. But at the end of the day, we do it together. And this got me thinking, maybe it's not a bug, it's actually a feature. This is how it should be done. And maybe we should stop asking the LLMs to provide answers, instead asking the LLMs to do this kind of debate and hopefully come back with a similar result or a result that is good enough and definitely better that we can start from. And do this autonomously on its own. And as it turns out, there is actually such a pattern. I didn't invent it. It's called multi-agent debate. It's when you let a series of LLMs, a set of agents to debate and reach a conclusion. Now, there are different variants to this pattern. It has actually been researched on different kinds of problems, like math problems, sometimes symbolic reasoning. I haven't seen a work that actually researched using this pattern over software engineer or system engineering kind of questions. And the different variants exist, but the basic pattern is that you have different agents, LLMs, essentially. Given a problem and a relevant context, they each give some kind of a proposal to how to solve the problem. And then the agents give feedback on the other agents' proposals. And then each agent receives all the feedback from all the other agents and refines his proposal. And this goes on for several rounds until at some point it converges by some criteria, different kinds of criteria, and another LLM, which I call here the judge AI, basically does some kind of a synthesis and produces a unified solution. So that's kind of the gist of this pattern. And the pattern itself is basically composed of three main components, right? On the one hand, we have the actual agent profiles. So basically, it can be a technical configuration, like which LLMs to use and different technical parameters of the LLM. And it can also be and it should be, in a lot of cases, very useful to have different personas or roles, if you want, for the agent. So how this agent should look and what should it propose. And then there is the other component, which is the topology of the debate itself. So essentially, who talks to who, okay? Whether it's everyone gives feedback to everyone else, whether it's just to specific neighbors, etc. And the third component is basically the convergence mechanism, or essentially how we reach a decision. When do we say that, yeah, enough is enough, and that's the debate is concluded. And that's the answer. Now, there can be different variants to this, like I said. For example, you could decide that a convergence mechanism is just a fixed number of rounds. So when we finish with X number of rounds, we're done. Or it can be some kind of review of how many open questions are left and whether requirements are answered, etc. So these are the basic components. And it's kind of important to understand why this pattern in this form is kind of more suitable for the kind of problem of system design that I presented in the beginning. What this allows, so instead of just an LLM proposing some kind of solution, and we as humans need to, of course, review it and provide pushback if necessary or highlight mistakes, it's letting the LLMs do it for one another from different perspectives using, of course, the context, but also their vast knowledge. So this allows the LLM basically to correct each other, highlight implicit assumptions, and all these kind of provide this kind of adversarial pressure that is important in order to really debate a problem and refine the ideas. Okay, and this is especially important for a kind of problem where there's no single correct answer, almost never. And it's also important for this kind of problem where we have different constraints and forces at play that often interact with each other, definitely, and often contradict each other. So this is kind of a good fit for this type of problem, having the LLMs basically debate. And I actually went ahead and implemented this pattern in a tool called Dialectic, which was originally a command line based tool. It still is. It can be used as a command line version of it. So it's useful in automations or as used by other, it can be used by other agents, etc. It also has a UI, a web UI version of it. And there's also an agentic version. I'll talk about it in a few minutes. But basically what this tool offers is the ability to configure different agents to participate in a debate with different roles. So you have the system architect, which kind of, focuses on the structure of the system. And then there is, and the different components and the responsibilities. And then there is the performance experts and security expert and testing expert. And there's a simplicity advocate and data modeling, etc. And this tool basically implements this protocol of propose, critique, and refine, done in several rounds, and eventually produces a finalized design recommendation in a markdown file. And it also gives you a debate report where you can see the different proposals, refinements, critiques, everything that went around in the debate you can dive into. It also gives you the ability to look into technical details like latency, how much tokens were spent, etc. Okay, so this is basically the tool. Now, I don't have time to give a complete demo here, but just to give you a taste of how it actually looks. So this is the web UI version, right? It's based on the same engine, but this is the web UI version of it. And if you look on the upper left here, we have a way to basically input the problem, describe the problem we're trying to solve, and then beneath it, we can see the debate configuration, so how many number of rounds we want, and the different agents and their configurations, etc. And then we hit start debate, and we allow the debate to run. So on the top right here, you can see this fills out as the debate progresses. And we can see the different proposals, critiques, refinements, etc., until we reach a solution, and this would be the final result in the bottom right here. Then you have the option to also provide some basic feedback, download, copy, etc., etc. And what this tool does, basically, behind the scenes, is implement the protocol which I just described. So there's the way it works, there's an orchestrator, which basically orchestrates the entire process and protocol. And one important feature of this, it's an optional feature, but it's a useful one. You can let the agents, given the problem, of course, in the context, each ask clarifying questions of their own, each from their perspective. For example, if you say in your problem statement that you need assistant to serve users and integrate in real time with other systems, it will ask you, the performance agent will most probably ask you, okay, how many users, concurrent users, and what do you consider real time? Does it have to be sub-second, et cetera, et cetera? So this is the kind of questions you would get. And as a user, you answer those questions, of course. And given those answers, these are fed basically as part of the context for the agents to debate. So they all the agents see each other's questions and answers, of course, given, and then they go into this cycle that I already described until at some point, the rounds are done and we go to synthesize a solution by some kind of a judge AI. And this is the solution given eventually. Now, I didn't just implement the pattern, I also tried to see how the different debates are affected by different variables that might affect. So what I ran a series of tests. General disclaimer here, these are not exhaustive steps. We should have probably more tests to test out various things. And there are also, given the results of the test, some follow-up questions as well. But even with this limited set of tests, we already know and learn from it a bit. So the way the tests were done was basically I fed each test with some problem from an architecture kata. So these are usually very focused problems. Again, there are greenfield in this case, and there are very constrained problems as well. It's not like a huge system usually. And then I try to sort of play around and systematically change different variables every time and run a test and see how different things affected the quality of the result. The quality itself, the judgment was done with LLM as well. LLM is a judge, and basically tried to score the quality of the result, not so much by the correctness of the answer, but by basically how much did cover the functional requirements, but also how much did it address, how well did it address the actual quality attributes like performance, security, and so on. Now, again, I don't have time, and in the links at the end, you can read a more detailed report of the result and the conclusions and some preliminary analysis. But I can already tell you that we see the effect of different problems. For example, we're already seeing the effect of clarification. So when we do give clarifications to the agents, and they're good enough, of course, we do see an improvement. And this is not so surprising because at the end of the day, we're providing more context, more focused context to the agents so they can debate, they have slightly more knowledge and idea of what to look for. Summarization doesn't help, so there is a built-in mechanism, also optional, for summarizing in case the debate get very long. It's a very naive implementation of summarization, and it's hurting the results, which again is not so surprising because we're basically losing nuance, we're losing context, we're trying to summarize a conversation. It turns out that too many rounds are not that helpful. It's usually not very helpful to do more than 2 or 3 rounds, beyond maybe 4. Beyond that, the quality doesn't go up. Okay, sometimes even degrades a bit. And the final finding that I think is interesting is that, of course, again, not so surprising, roles matter. What is interesting about it is, so roles matter in the sense that what roles for the agents you choose to have in the debate, they of course affect the results. So for example, if you don't include a security agent, the quality of the way the result addresses security concerns will be less good than if you would have included a security expert. It's also a way to sort of provide weight to some aspect that you would like to emphasize. For example, if you want the debate or the solution, the eventual solution, to be more simple, if you would like to emphasize simplicity, you would include not one, but maybe two simplicity advocates in the debate. You have the option to do that, of course. So if you include two simplicity advocates, they will, of course, advocate for simplicity, and you will see that the result is sort of leaning more toward a simplified solution. Same goes for security, performance, etc., etc. So this is important because it's a way for us to sort of weigh different or emphasize different aspects or different qualities that we want from the result. Okay. And I think this is important because the key message here, I think, is that when we apply this pattern to do design debates and eventually produce some kind of a design suggestion, at least a draft, it's important to sort of design the debate itself. So think about how we construct, how we configure the tool in order to provide the result that we want, or at least the result that we hope for in terms of quality and emphasis. It's not just throwing a bunch of LLMs at the problem. Okay, we of course let several LLMs sort of debate and discuss, but we want these LLMs to really, we want them to debate in a way that we would like. Okay, so that is important. And another version of the tool, which I mentioned earlier, is the agentic version. So the dialectic agentic, it's called. And the main idea here is it's basically the same tool, very similar functionality, the same pattern that is being implemented, only now it's implemented not so much in code that basically does all the wiring and the LLM calls, etc., and manages memory and state and so on. But in this case, it's a set of skills that is then deployed and used by some underlying agentic platform, things like Claude Code, Cursor, Codex, and so on. So once we have this agentic platform, this underlying platform, we can deploy this set of skills and let it run, again, given a problem, a context, and some basic configuration. This makes it easier in a lot of ways. First of all, it integrates better with our current tool set and the way most people in this industry work. It's also easier to integrate with other components like tools, allow tools, etc. So in that case, we have different agents. They communicate with each other by reading and writing files, markdown files, and eventually produce the same results. The protocol is the same, the implementation is different. So it's easier also in this case, for example, to provide some ad hoc instructions for a specific debate because it's part of the prompt that we give and when we activate the skill. It is slightly harder to test because, again, it's an agentic platform. There's a full harness there beyond the skills, and it's probabilistic in a sense. It's stochastic. So sometimes it works in slightly different ways. And it also tends to be more token intensive. So a lot more tokens are used. Okay, but that's the pros and cons. This is, again, just an illustration basically of how this works. So what we see here is not so, it's a UI, but it's basically a file system of a workspace where this was run, a specific debate, in this case, 4 rounds of a debate. So what we see here basically is just Obsidian with 4 markdown files open. So on the top left here, we see the problem file, basically, of one problem, of course, presented in different requirements, etc. On the bottom here, on the bottom left, we see the summarization of all the clarifications. So the clarifying questions the different agents ask, and of course, the answers I provided to them. And again, this is a file that summarizes all of the questions of all the agents. On the top right, we see a progress log that was written while the debate was running. And in the bottom right here, we see actual synthesized final solution, basically a markdown file with all the draft of the solution. Okay, so This is basically it looks, and you have all the files, all the proposals, refinements, critiques, etc., available on file system with whatever extra information and metadata that you need. Now, at this point, I'd like to go back actually to my original question, which was not exactly about design, but how can we improve the overall productivity when it comes to software engineering in general with LLMs, right? And one thing to observe, I think at this point, we have different tools that address different parts of the life cycle. We have, for example, spec-driven development, which is used to provide and write specifications. And there are tools for listing requirements and doing things like writing the requirements documents. We just discussed design, and we have other tools for design of software and some probably other tools as well for design of systems. We have, of course, coding agents, which we all know and love. And we also have tools for testing, debugging, observability, and all troubleshooting, and so on and so forth. The question is, what happens, or how can we bring all of this together? Because I think we can bring all of this together to a more complete. And I think the way it will actually evolve to is it's going to be some kind of an autonomous development. Okay, the software development lifecycle is going to be more and more autonomous. And when you think about it, we really have all the pieces together. It's just not, we're not there yet, but we're not that far from there as well. And I can imagine a future where a developer or a human in general provides a business requirement, and then we have some kind of architectural debate like we just discussed with providing an architectural plan and draws from the existing system state. And then we have some kind of a technical specification, which produces, of course, a technical specification, but also a specification of a fitness function, basically a way to observe and measure the quality, the architectural quality of the system. Of course, we have then a coding agent, which provides codes for these two things. And then we have continuous deployment mechanism, which eventually deploys, of course, everything. And this becomes the new kind of system state, right? How do we observe the system, and also how we're the system implementation itself. And this, of course, becomes the new state and sort of the starting point for other evolutions. And I can definitely see a situation where a system evolves this way pretty much on its own, of course, with humans guiding it. And the human part is important, because I don't claim that software systems should evolve on their own. Okay, there are some, let's say, claims out there about the dark factory, which is nice. It could be there, but I think humans still have an important role to play in two areas. First of all, humans provide, of course, the requirements and the business trade-offs and the prioritization. So all of this still remains important. I think this is still an engineering job. Humans still need to think how to look at the system, how to understand how it operates in order to provide some guidance, feedback, etc., to the AI. And of course, innovation is important. But also humans provide this kind of human friction, if you want, in a good way, because at the end of the day, these software systems affect human lives, and humans need to be there to provide the safety and kind of ethical framework for how these systems should evolve. And I think humans are critical at that point. Just to summarize this, I want to kind of highlight 2 points and 2 questions to make it much more practical and focused. So the advantages, what are the advantages of using multi-agent debate system over just a single AI? And I've mentioned this, but it's important to sort of reiterate on the key points here. First of all, the basic idea, the basic motivation is for AI to autonomously surface and test assumptions. Okay, it is important to have the AI sort of stress test each other to eventually provide better reasoning, minimizing blind spots, etc. So that is the key, let's say, strength and upside of this pattern. Okay, and usually we get more comprehensive results. We can cover more aspects, etc. Now, how can you apply this in your day-to-day work? It's, of course, depending on your workflow and your work environment and constraints, but you can already implement this with the given skills that I just mentioned, or CLI tool, etc. And, with the given system context that you already have for the coding agents, which can definitely be used as well. It's like having, and this is actually a quote from a colleague of mine, which I presented the system to, it's like having your own private consultant at your disposal with a vast knowledge of the world, of system, of technology, and you come to it with a specific design question with your constraints in the context of your company or your team, and he gives you some answers. And you can basically use that as a draft. It's also useful to use it as sort of, given that you have some kind of a draft design, you thought of something, you want to weigh the alternatives, you can also use dialectic in this pattern as a way to provide a sounding board for you. So you give it some kind of a draft, you present a problem, and you say, okay, does this work? What do you think about the solution? Help me to uncover other things. And this can definitely help you there. Okay, so we just went through how we can leverage AI for more than just coding. Basically, how we can do structured multi-agent debates on system design. I presented you also with dialectic, and I invite everyone to use it, provide feedback, suggest improvements, and think together about what more we can do with AI when it comes to software development. Thank you very much.